Welcome to your first time taking notes at home. Today you will be learning about you're going to describe to me restricted/discontinuous domains and ranges. 2B, you were learning about continuous domains and ranges. So on both sides there would be arrows that go on and on forever and ever, and there's no break in the graph. Well, here we're going to have discontinuous parts of the graph. So restricted meaning the graph cannot cross certain spots, or discontinuous meaning the graph will stop. So the graph could have a stopping point in it, and it's another point where it starts back up. Restricted, these are kind of like asymptotes. So that's what 2C will be. So looking at example 1, we have a radical function, a square root function here that looks like it starts at a point. Put a point there. Starts at a point. That point is approximately 1, -5. It's always good to know a starting point for a domain and range. Remember, domain are the x values. So if we're looking at our x values, the x values start at 1. There is an actual point at 1. It's an actual coordinate. And in fact, remember from middle school, with inequalities, a filled-in circle is equal to, so we do less than or equal to. It's an actual coordinate on the graph, so we wouldn't need to include it. This graph then keeps going in the path that it shows us, and it continually goes. So like at this point right here, it's at 6, it's x, or x. Now it's at 8. Over here it's going to be at 10, 12, 14, 16, and it continues in this pattern forever and ever. There are no breaks in it. They would show us any breaks that were in the graph. So that shows that it's continuously goes on to the right on the x values is infinity. So we say the x values include 1 and go to infinity. The range, you talk about the y values. It's the lowest y value of this graph. Looks like it's at -5, so the y values. So the -5, again, this point is included, so we need to include it, less than or equal to, and including, same thing. Y value, and as we follow this graph, it looks like it's continually creeping up just a little. It's going to go up, and there's an arrow on it, so it's going to be continuous, continually going up as it goes to the right. And the up portion is the infinity. So it'll continually rise up above the x-axis, continually rise above the x-axis, and eventually it'll go into positives and it'll go to infinity. So this is your domain and range for this graph. Example 2, same thing. You need to describe the restricted or discontinuous domains and ranges. So this graph, we have two things going on here. We have something we've talked about in class, this asymptote that runs right at x equals -3. That's the equation for the asymptote. X equals -3. And then there's this other thing we have not talked about. This is here, right here. And it looks like it's a hole. And that's actually what we call it, is a hole. And that hole is at x equals, it's always the x values we'll talk about in this case. The x value is at 0. So let's talk about the domain of this. So I always read in a book, and I'm going to read from left to right the graph. So think about it, it's going to continually go off to the left. So when I read this, I start over here, and I'm thinking it's going to go from, it's going to keep on going to the left. So I'm reading from the left, so it's going to come from -infinity. Remember, less than that can't be equal to -infinity. Less than x, and it's going to continue, and it's going to run into this asymptote. or run right next to it. You cannot touch the asymptote, so it's going to be x is less than, and then what's the asymptote at? -3. That is one part of our domain. Now we need to describe the other part of our graph here. The other part goes down here, runs along the asymptote, so it starts again at -3. And then it runs all the way until we get to the hole, and that's a break. That's a discontinuous part of the graph. That's a hole. So we say x is less than, where's the hole? The hole is at 0. And the last part, we need to describe after the hole what happens. And it continually goes on forever and ever. So from the hole is less than x, and is less than, and it continually goes in that to the right, which is positive, like 8, 10, 12, it keeps on going. So we'll see it goes to infinity. So there are 3 different portions to our domain to describe this domain. And in class I might describe this. There's another way to write this, but I'll talk about it in class. Range. Range we need to talk about how low to how high. So we have, looks like 2 different parts of the graph. This one on the left here, that's going to go down, and then this one. There's 2 different parts. They both are going down. So they're going to go down all the way to infinity, negative infinity. So negative infinity is less than y. And then as we're going up on the graph, just pick one of them. The first thing that I run into with, where it's discontinuous, is the hole. The hole is at the y values is -2. So it's going to be negative infinity. The graph is going to go all the way to -2. And but the problem is that I see is there's an actual point over here at -2. So scratch that. That isn't quite right. So it does go to -2 on one part of the graph, but the other part of the graph, actually, there's a point there. This runs all the way along. So it's kind of like, it's almost like that, just because there's a point here, it fills that hole in. There is a point at -2. So then, just think of it as it continues to go on and on and on, both of them. And so our range ended up being negative infinity to infinity. So even though there is a hole on part of the graph, you have to look at taking into account both parts of the graph to be able to talk the range. I will have example 1 is going to be my entrance ticket. So the quiz when you walk in is example 1. Thank you.